like to help review for the Unit 4 test. To solve this one, you add the 2 over, divide the 2 off, then you get this, then you got to switch this to the other side, at least I do, because I'm going to be switching to a log once you get to here. And remember, when you switch sides, the inequality has to switch. Then you change it to a log, and the inequality switches again. And remember, when you make a log, you put the word log here, and you switch these two. That's what I got here. Then you get rid of the 6, you multiply both sides by 6, and then you get this. Now you might wonder, where did I get this 3 from? Well, look over here. Log 27 base 3 is equal to 3, so that's a 3. Oh, so 6 times 3 is 18. Now why did I flip-flop sides again? It's because this is x is greater than 18, so I flip-flop it. So watch out, there's a lot of flip-flopping of the inequality. Best thing to do is when you're done, maybe think about the answer. My answer is values bigger than 18. So think of, will bigger than 18 make things larger than 52? I'm sorry, would 52 be less than those? Meaning, would those values be larger than 52? So it's always good to maybe think about it when you're done, plug it in and try to make sense of it. It also can be a little difficult. So for this one, I'm going to minus the 1 over, divide off the 6. All right, now I got this. Now I change it to a log, so I put the word log, switch these two. Don't forget to switch the inequality when you do that. Minus the 9 over. Don't forget log base e is ln. And then I always like to put the x on this side. So make sure when you flip-flop these that you have the flip-flop the inequality. Now why did I put the 9 in front and not behind? Well, if you put the 9 behind, you might go 4 minus 9 and mess some things up. So I like to put it in front. And make sure you go negative 9 plus ln 4. Don't do negative 9 ln 4, because then you might think it's a multiply. Just some common mistakes I see students do. Now for this problem, you just got to read carefully, and what you realize when you read this problem is it talks about 5,000 being the initial value. You hear the word continuous rate of growth, so it's E. The rate goes here, and it's saying it's growing, so that's why it's positive. This is how long it takes. And then there's a phrase, but this is at most or at least. Well, we read the question, and it says in this problem, it talks about the word at least double. So we double 5,000 would be 10,000. At least, well, becomes a greater than or equal to. You got to be careful with the at least and at most. It can be tricky. Now for this one, you read the question carefully. It says it starts with $400. You're spending, so you're shrinking by 20%. So 1 minus 20%. X is how long it takes. And since it says equation, you look at equal sign, and we need to know when it equals 100. So remember, starting, ending, rate goes here. If it doesn't say continuous, it's either 1 plus or minus the rate. If it says continuous in it, then it's talking about a natural compounding continuous effect. So the rate, E goes E here, and the rate goes here. Just remember, this does not need 1 plus or minus, but it does need the plus or the minus, but it's not 1 plus or minus. Pluses are growing, negatives are shrinking. Negatives shrink, so you minus from 1 down here, growth or plus the rate. So just be careful with that. Start, end, continuous, non-continuous. Be careful with it all. Now this problem's a little different. It's kind of like graphing logs. All I'm doing when I say f of 1 is say put 1 right here. 19, put 19 right there. 3, put 3 right there. And what you'll notice is when I put 1 right there, I get negative 2. And you can't have a negative in a log, because 2 to the what power is negative 2. That doesn't make any sense. So that's undefined. Same thing with 3, because watch, 3 minus 3 is 0. You can't have a 0 in a log, because 2 to the what power is 0. It doesn't make any sense either. So these are both undefined. So let's look at 19. When we put 19 in, it's 16. So 2 to the what power is 16, that's 4. So that's negative 24, and 8, negative 16. So simply plug it in, and on the tests and stuff, either it will work out nicely, meaning the log will break down nicely, or something's going to be wrong. I won't give you one where you can't find the log or some sort of crazy decimal. So these next ones we're going to expand. So to expand this, what you have to realize is this is going to be 3 logs. That's where these came from. If it's on top, it's a plus. If it's on bottom, it's a minus. And then any powers, then jump in front. So that jumps in front, that jumps in front, and we're done. We expanded. Just make sure you keep the base the same through all of them. So when we condense, we're bringing these together. So what we have here is, first step is you take any things in front and make them powers, right there. Make it a power. Then, once you have your 3 pieces, they're all ln's, you put ln, and you're going to put it all together. So the 5 squared is 25. That's a plus, so it's on top. That's a minus, so it's on bottom. Just remember, pluses are on top, minuses on bottom. And remember, if it's in front, it can be a power, or if it's a power, like here, it can go down in front. It goes vice versa. This is called expanding. This is called condensing. Now, if we want to write an inverse, first step, switch x and y. Then we just solve. Minus the 8, divide off the negative 2. Then I switch-swap sides so that I can easily make this into a log, meaning I put the word log here, switch these two. See right there? Then I get this big ugly mess. I added the 9 over. And remember, you don't need base 10. Base 10 you can just write as log. So here's what this whole mess looks like. The inverse of all exponents are logs. Just be aware of that. Now I'm going to solve this one for x. And if you notice, x is in the exponent. So to get that x out of the exponent, you know you're going to end with a log. Just be aware of that. So minus the k over. There we go. I divide that negative off. A lot of people miss that. They don't see that as a negative, something to get rid of. So I have to divide that off. And that leaves us here. Now understand, when you divide, you're basically changing both signs. So I changed both signs. Then I flip-flop sides. There we go. Now I put the word log here and switch this with this. Then log base e is ln, as well as I minus the g over. So this becomes ln right there, and I minus the g over. There is it solved for x. These are very similar. The big difference here is you're switching x and y and then solving for y. This has more numbers. This is just like a whole bunch of letters, a formula that we're rewriting. The most important part of this question right here, even though it says find the y-intercept and rate for each function, the most important part are these questions. You want to compare the y-intercept and the rate. So let's go one by one. This one, the first step here, whenever you have a negative power, is make this the reciprocal, so that's a 1/5. All right, and so our y-intercept is always the front unless we have a shift up, which we do. So we do for this one. So it's 3 plus 2 is 5. That's my y-intercept. Now my rate, why is it negative 80%? Well, what I want to do is I want to change this into a decimal. 1 divided by 5 is 0.2. Then I got to think, okay, 1 plus what, or 1 minus what is 0.2, and that would be 0.80. So you have to think of this as 1 minus something, because it's below 1. So that's where the negative 80% came from. You have to think carefully about what is happening. So, and then we'll come back to what this is saying in a second. Right here, you have to understand there's a 1 in front of that. You have to understand this is 1 plus 0.06. So we know right there that is our rate, and it's positive, it's growing, bigger than 1. And our y-intercept is 1. Oh, but shifted down 5, so it's negative 4. Next one, my y-intercept is 2 plus nothing. See, I put 2 and 0 there. I actually put a 0 there just so you see that as 0.60. That's important in a second. Your y-intercept is 2 plus nothing, so it's 2. Why is this negative 60? Because that negative 0.6 is 60% in the negative decaying fashion, so it's dropping by 60%. Next, remember when we have a negative power, you want to change this to reciprocal, so that's 5 to the x. Then you also want to think for rate purposes, you want to think of 5 as 1 plus what is 5, and so that's 1 plus 4. So my y-intercept is 3 plus the change, so 3 plus the shift up is 4. And then the rate is, remember, it's growing, it's bigger than 1. And how much bigger than 1 is it? It's 4, so it's 400% growth. Always remember, negative powers, switch them. It messes you up if you don't. This one, you have to understand there's a 1 in front and a 3 right there, so you start with 1 but go up 3, 4. And on continuously compounding, the rate's right there, so you're growing by 7%. Be careful, don't call that 70%. Do not call that 70%. This next one, that's 0.83, which is less than 1. So we think, what do I subtract from 1 to get 0.81? I subtracted 0.19. All right, so 0.19 means negative 19%. That's how much I took away from 1. And then 8 dropping by 7 is 1. So my questions are, what is the largest y-intercept? You just simply look at them all. The largest 5, negative 4, 2, 4, 4, 1. There it is, the largest y-intercept. Which has the largest rate? Well, just look at all the rates. Okay, boom, 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 boom. The largest is right here, 400%, which is decreasing the fastest. So decreasing means we only look at negatives. So negative, negative, and negative. Which one's decreasing the fastest would be that negative 80. It's the biggest negative, so decreasing the fastest. And which function is increasing the slowest? So you look at the increasing. So you have this one, and this one. The slowest is this one, so that's increasing the slowest. Tons of questions you can be asked when you compare. Remember with exponents, if it's a negative power, make the reciprocal. Otherwise, the rate is in the base, and it's how far from 1. Okay, now if it's an e, the rate is in the power. Just to keep track of those. For this last section, we're going to answer a lot of questions based on this graph. This is f. See right here, f. So as x gets larger, what happens to the y values of f of x? Well, as x gets larger, so as we go this way on the graph, aren't my y values getting smaller and smaller and smaller, just kind of slowly, but they're getting smaller. All right, here, how do you write the function? Well, for writing the function, understand it's a multiple choice test. So to get it, the first thing you want to do is look for the asymptote, and you should see the asymptote's at 1. So that should tell you it's going to be x minus 1, because the asymptote is right here. It's about to shift, because it's normally right here. It got shifted over. All right, next, what you want to look at is how far from here, from the first dot, did it drop? And you should see that's a drop of 2. So you should know it's a 2. And the negative, how do I know that? Because it's going down, it's upside down. Now how to get 4, that's a little bit harder, but it's kind of not as hard as you might think. To find the 4, if it's multiple choice, you kind of just, hopefully they'll all be 4. But if it's not, what you do is from the asymptote, you go over 1, 2, 3, 4, and then you go down 2. Again, 1, 2, 3, 4 is your base, and this is your A. That was actually the easiest way altogether, is just to see this as over and down. Over 4, down 2. And this is your asymptote. So asymptote, over, down for the second dot. Next, what is the average rate of change? Well, from 2 to 5. So from this dot to this dot, what's the average rate of change? Well, you could say, oh, I went down 2 over 3. Done. That's the easiest. Down 2 over 1. Done. Or you can think of this as 2, 0, and 5, negative 2, 5, negative 2, and I did the slope formula. That works too. You just did y2 minus y1 over x2 minus x1. So either way, this one is f of 2, which is 0, f of 5, which is negative 2. So what's 0 plus 3 times negative 2? Well, that's negative 6, so it's negative 6. What's my domain? Well, my graph starts at 1 and goes forever over. Now 1 is not part of the graph, it's an asymptote. So that would be 1 to infinity. You could also write it as x is greater than 1. My y-intercept, well, where's across the y-axis? Well, it never will. My y-axis is right here. Sorry, my asymptote's right here, which it will never reach the y-intercept, so there is none. That's kind of a tricky, watch out for that. X-intercept is right there. That's at 2, 0. What is the equation of the asymptote? That's this line that it never crosses. Even though it looks like it's touching it, technically it doesn't touch it. But that would be x equals 1. What's f of negative 2? So f of negative 2 would be out here somewhere, and there's no value. Over on the side of the graph, it never gets there, so there's no value at negative 2. So that's why it's undefined. F, what's happening? Well, it's dropping, so it's decreasing. That's kind of like this one over here. What interval is f of x positive? So for this graph, where is it above this line? Well, it's above that line right on that interval right there. From 1 to 2, it's above, this is the x-axis, so it's positive right there, which is between 1 and 2. If I ask for its negative, it'd be from 2 to infinity. Now we're putting in a new graph. So we're going to graph this, and we're going to add. So it was 11 questions based on this picture to start with. Lots of questions. So to graph this, what we first do is we want 1. To graph it, we want 1 and the base. The base is e. So 1 and the base is the numbers we want to plug in to graph. So when I plug in 1, ln 1 is 0. So 3 times 0 is 0, minus the 1 is negative 1. So over 3. So, over 1 and down 1. There's my dot. Then I have E. ln E is 1, so 3 times 1 is 3. 3 minus 1 is 2. So that means I go over E, which is 2.7, and up 2. So over 2.7 and up 2, over 1 and down 1. I know my asymptote, since there's no shift here, is the y-axis. And then I sketch my graph. So there's no question here, it's just the graph. And the last one is approximate the solution of g equals f of x. So this is g and this is f. What's the solution? Well, it's right where they cross, which is 1 point something. I said 1.7. Somewhere around there where they hit. Good luck with your test.